everyone. We are on lesson 11. We are on rectangles. So if we look through the first question together, it says, Mr. Coy wants to build storage buildings, so he drew plans for the buildings. Of the buildings are related. How will the areas of buildings A and B change? How will the areas of C and D change? List using the graphic organizer. So we can see A, B, C, and D are all listed. So let's get to it. Reading the problem. What do I need to find? I need to find how the areas B and from C. So when we're talking about a rectangle, for me to use, when you look at the examples up here, you use what they give you, left and right sides, and what they give you for width. Will we use this information below to help? Then I will look for a pattern to see how the areas will change. If we were to go back, 8 feet long and 4 feet wide, which means the area would be 12. The B is also 3 feet wide, 3 feet long, but it's 8 feet wide. So the area would be 24 square feet. Remember, we talked about multiplying the area for the length of the area. If it's a perfect square or a perfect rectangle, equal arrays. Building C is 6 feet long and 8 feet wide, so that area is 24 square feet. And for building D, it is also 6 feet wide, 6 feet long, and 8 feet wide, would give us 48 square feet. See, but the width, if you double 4 plus 4 is 8. If you double 4 plus 4 is 8. So the areas change if we're looking at A and B from 12 to 4, and then we're seeing B 24 to 48. So when the length is the same and the widths are double, the areas, is there something you notice between 12 and 4 and 28? The areas are also 12 and 24. Try another one. Says Mr. Coy is building more storage. How will the buildings E and F change? How will the buildings H change? Use a graphic organizer. So what do we need to have? The will change, and we're comparing E and F, and then comparing G and H. What do I need to use the length and width of the buildings. And with the first one, how well is it? So I will create a table. All right, so building 5 feet long and 8 feet. F, 5 feet long, 4 feet wide. G, 10 feet long, 8 feet wide. Building H, 10 feet long, 4 feet. Now, let's fill in our area. For building E, the area would be 40. Building F would be 20. Building G, 80. Is there a pattern you notice? Pattern E and F, and then G and H. So the lengths are the same, but the width. If you look at the widths in this one, they're getting smaller. But how much are they getting smaller by? They're dividing them in half. 2 is 4. So if they're cutting widths in half, then the areas are also cut in half. So how did the table help you find it? Maybe something like the table made it easier to see the reasons. Really, okay, so but the widths are different by how much they've been cut in half. Okay, let's keep moving together. Says many pools complete the table by finding the pool length. There is times 60 times 30, 4 times 4, 3, 8 times 5, 400. I like to just think of it as you're multiplying with 8s normally, like 8 is 16, but instead of a 2, it's a 20, so I add a 0 on. So we filled in our chart. Then let's look at our patterns. So the blank stays the same. What is the same in all shapes? The length. Now, look at what we notice. 20, 30, 40. The width increase. High. Describe the pattern of how the area so in 60 increasing does it increase each time? Answer by square feet. Says what if the length of each pool was 16 feet? How would the areas change? So instead of 8, if it was 16 for each of them, there's something we know about the. Yes, if we were to double 8 or 8 times 2, we would get 16. So if we're doubling the length, what do you think might also double? And last but not least, let's look at question 3. It says Elizabeth built a sandbox that is 4 feet long and wide. She also built a flower garden that is 4 feet long and 6 feet wide. She built a vegetable garden that is 4 feet long and 8 feet wide. How do the areas? So I'm going to take this information, just make a chart like I would with the other ones. We have a sandbox, flower garden, and we have a vegetable garden. So we have our length and our width. Let's find our area as well. So the sandbox is 4 feet long and 4 feet wide. The flower garden is 4 feet long and 4 feet wide. So let's figure out our areas. 4 times 4, 16, 24, 4 times 8, 32. So how do the areas change? So let's compare the 16, the width looks like increase by 2 each time. 4 plus 2 is 6, 6 plus 2 is 8. The area, well, the difference between 14 is 8, but the difference between 2 and 24 also 8. So the areas change. They're getting bigger. Increases. 8. What are we talking about? We're talking about feet. Okay. On your own, a lot of questions. You have 1, 2, 3, 4 questions. 2 of them because it's not. And then we will go over the answers tomorrow. It says draw a bar model. That's why they give you so much over